The second most used open source project recently celebrated its 10 years anniversary. I am speaking about Kubernetes. The famous container orchestration platform is used by pretty much any company with a modern stack. So in this video, I want to cover a specific topic that's actually not about Kubernetes, but kind of the step before, which is when you are building your container images. These images tend to become more sophisticated and heavier, and obviously they are a very important part of your stack. A recent survey found that just in the span of a year, the respondent reported that the build time of these container images had increased by about 16% just in 1 year. That's quite a lot. So in this video, I will cover 3 tips to improve your container image build process. 2 of them are going to be specific to Docker with Dockerfiles. One of them is going to be about increasing the build time. The second one is going to be about decreasing the total size of your container image. And the last one, which I believe is less known by the industry, is going to be using the pack CLI, leveraging the Buildpacks implementation. Let's dive in. So the first tips, which is specific to Docker files, is the step ordering. Now that's probably the most known optimization trick in the industry. Step ordering has been around for a long time, and that's the idea that Docker is gonna be using layer caching, right? So when you have a Docker file, I'm gonna use a Python application here, and let's see, I will use what I call the wrong Docker file, but you basically describe steps so that you tell Docker how to build your container image. Now, the order of the steps matters. So the way it works is that when Docker will build your container image from a Docker file, it will see if you already built this image, and if so, it will attempt to use cached layers. Okay, so every steps can be a cache layer. Now, if one of the steps needs to run again because it has changed, for instance, here, if we take this step, we are installing system dependencies. So let's say I'm removing or adding a dependency to this list. Docker will need to run this step again, right? It cannot use a cached layer because it's different, right? So anything that's above this apt-get instruction, Docker will attempt to use the cache. Everything that's below this instruction, it won't use the cache. Okay, and so why does this matter? Well, if we look at this example, for instance, the first step that is here is where I'm copying my application, into this application folder. And so every time I'm changing my application to fix a bug or add a new feature or whatever it is, everything that's below, again, when you build your container, will need to be run again, okay? So now what's the right way of doing it? So the right way of doing it, for instance, in this example, is to place the step where you will copy your application code into this folder at the bottom of your Docker file. So that anything above, here, for instance, we are installing Python dependency and the example of my system dependency here, Docker will use the cache layer, okay? So what can you expect to gain from doing just this step, for instance? I ran a test on my server, and I ran it about 10 times to make sure that it was a good data set. It took me a minute and a half roughly to
rebuild the container image using a Dockerfile after I had changed the application code. When I used a Dockerfile where the ordering was optimized, it took me 300 milliseconds, so pretty much like 99% faster. So this step ordering is really crucial, and the rule of thumb is that put what's not likely to change at the top of your Dockerfile and put what's most likely to change at the bottom of it. All right, now let's jump into the second tip. So this one is also specific to Docker files, and it's the multi-stage build in Dockerfile that I'm going to speak about here. I'm going to be using a Java application to illustrate why this is useful. So let's look at a simple Dockerfile, a non-multi-stage one. Okay, so it's very basic Java application, and a reminder: if you want to run a Java application in a container, the way that the process is going to go is that first it's going to build a jar file, and then it's going to run this jar file. Now, to build a jar, you will need a lot of dependencies. Okay, a lot of dependencies that you need to install. But once you've built this jar, these dependencies, that are on system, you no longer use them, right? And they take up a bunch of space. So what Docker allows you to do in this case is to break down this process into 2 stages. And the way you initiate a stage is with the from statement. So here you can see that I'm using that's my first stage, the build stage, I called it, where I'm going to build my jar file. And then I declare a second stage where I'm going to take this jar and get it ready for runtime. And so anything that's in this stage is not going to be imported into the second stage. So my image is going to be much lighter. And so again, here I ran a test, and with the former Dockerfile, the non-multi-stage, for this specific application, and I installed like a bunch of dependency, to make the file, the container image fairly heavy, to simulate like an enterprise application. I installed Spring, Kafka, and a bunch of other stuff. So the image, the container image was 1 gigabyte with a regular Docker file. Now with the multi-stage approach, I was able to get it down to 500 megabytes. So that's 50% lighter, which is a huge improvement. Okay, so now let's jump into the third one, and I think the least known of the 3 tips. And in this tip, we will use cloud native Buildpacks. And more specifically, we will use a specific feature using the pack CLI, that's command line that you can install using your favorite package manager. It has a rebase feature we can see it here. So let me explain a little bit how is this working. So what's really cool with Buildpacks and the implementation of them is that when you build a container image from it, it's separated into layers, and you can swipe out this layer without changing the other ones. So again, if we take the example of an image built with Docker, if you change an instruction, all the layers below will need to be rerun if you build a Docker file and this step has changed. Now, in the case of Buildpacks, you can swipe any of those, and you don't need to run again the other ones. So let's take an example where you need to apply a security fix on the OS layer, and you need to do this very, very quick because it's a critical vulnerability, you need to do this as soon as possible. So using the pack rebase command, you will be able to swipe out to replace this OS layer without having to modify any of the other layers. And so here again, I ran an experiment, and I used a Python script to do that. By the way, all of the Docker files and the scripts, I will paste links to them in the description of the video. It's on my GitHub, so if you want to play with them and look again, how I did the ordering and the multi-stage, and check out this benchmark, you can do it. So, I won't go too much in detail, but basically I did it with an Ubuntu example where I take an older version of the OS. I build my image, and then I rebuild it using a newer version. In the case of using the Pack CLI, I just again swipe this layer. And so I ran this like about 10 times to have enough robust data set. And using a regular Dockerfile, I was able to rebuild an image in about 2 minutes, 20 seconds, 26 seconds to be correct, and using the Pack CLI in 43 seconds. So that's 70% faster. So it's, again, like a major gain. I won't go over all the other advantages of using Buildpacks, but if you don't know about them, I would invite you to check them out. And it's not just for, it's very well known perhaps in the Cloud Foundry community, where it was really virtual machine centric. But now the ecosystem is offering more, and actually you can get the same developer-friendly the Cloud Foundry experience, but instead of running virtual machine, it's running container images. I won't get into details, but anyway, that's here you can gain again a major performance improvement. And so yeah. To conclude this video, if you are running a small infrastructure with maybe a couple of container images, and you are not running anything at scale, you might not care about that, right? But as soon as you need scale, and perhaps you have a large team of a developer, and you have a CI/CD pipeline, and your architecture is distributed, and every second, every minute matter to keep the velocity of your team to stay high. All of this will make a big difference, right? Like 99% faster to rebuild an image, to build an image, with the correct step ordering. Using multi-stage, I was able to decrease the size of the image by 50%, and using the pack rebase feature, I was able to rebuild and replace a layer of my container images 70% faster. So it adds up. I'm sure if you bring this performance improvement to your team, your coworker and your boss are gonna love you. That's it for today. I hope that you enjoy these tips. If you have any question, please ask them in the comments. If you know other ways to improve your container build process, please share them in the comments as well. Thank you for watching. Bye.